Oh, and by the way, I posted also the other lectures, like the Zoom recordings, in 3 parts because it was kind of long and I had to edit it a little bit because I forgot to, during the break, it was just a blank screen forever. Okay, so welcome to our new lecture of IBA, and we're going to go over some examples of recording emotions and micro expressions, and then playing with that whole open pose and our methods and so forth. Some steps to analyze the micromotion trajectory. So the first thing that I did was to create a reference set where we could have anger, contempt, disgust, fear, happiness, sadness, and surprise, the 7 universal facial universal micro expressions, and I call them like the 7 fume or fume signatures. So here's anger, and I just took her video and was sure to include like all the angry, like the anger stuff, and created like the frames for that. And so that's just anger. And then I will use that to create the .mat file with a wrapper that Joe Vero created. And we'll go over that in class today. Here's contempt. So I did the same thing. So I just went and looked for all this Merck thing, all the contempt stuff. So you see that it's short. So I made sure that it contained that. The same with fear. The happiness. Okay, sadness. And surprise. All right, so they're very short, and they're just to create those reference points, and they're not perfect by any chance. So here's the whole thing. So I create the reference points by passing those snippets to open pose and create the skeleton, the whole grid, and then convert that to speed data, standardize that to get the micro movement spikes, run the gamma parameter estimation to build the 7 reference points on the gamma moment space. I believe, and I had to check the code, that I took a 1 second and 10% overlap of the whole movie, which I'll show you. So this is the whole movie. Let me just get the thing. That's the whole movie. And then what I do is I quantify, after taking this 1 second with 10% overlap to get gamma frame by gamma frame, I quantify from each gamma moment point to each reference point. I quantify the distance. using the air mover's distance, using the histogram, so histogram by histogram, and then localize this sentiment of the narrative. So where is it falling in that space? So this is the whole movie that OpenPose creates, and then creates a .mat file that Joe wrote the wrapper to create. And so we get, so this is about 18.25 minutes long, 30 frames per second, and about, I know I had to check because I think my windows were 1 second long. So, but it's in the code. And
so
this is the
speeds,
result. Yes, go ahead.
The in the previous slide.
Yeah.
Let me say, get the raw speed data. The speed is for each point that OpenPose has identified on the screen.
Yeah, so OpenPose creates basically a trajectory of pixels.
Okay.
For each one of these 69 pixels, it creates a trajectory,
okay,
which is 18.25 minutes long in this movie, for example. And we can settle on some length. So that means that it has, yeah, it's quite long. So we can take, and that's what I'm saying, that I have to see if my intervals were 1 minute long. So once you take this position, which has X and Y at time T, X and Y at time T plus 1, time T plus so forth, we differentiate. So we take position at time T plus 1 minus position at times T. That gives us delta X comma delta Y, and we take the norm of that, and that gives us one number, one scale. So we go from one two-dimensional vector to one scalar, and the scalar is the speed. I see. So that's in pixels per unit time, which in this case is 30 frames per second.
Okay.
Then, so that's going to give us a whole bunch of wiggles. And then we pass that through the build record amplitude, and that gives us the micro movements, the gamma signatures, and everything. And we do that for every, however long we decide, 1 minute. If it's 1 minute, I think was good. I have to check the code because now I'm confused about that. And create then the trajectories. But the first thing is just the 7 references. Now, of the 69 points, we divided into the red zone here, which is like the eyes and the eyebrows and the part of the nose and so forth. The blue points, which is kind of the nose and the upper area of the lips, and then the lips and the whole face part. So these are the 3. So this one has like 28 points, 14 points, and 27 points. And each one of them are a trajectory. It's like this is a neutral expression. And like you see, there is a little bit of motion there in the dots. So those are that's the trajectory of the dots. It's very small, pixel per pixel. But it's enough that when you plot it, you see the peaks of the speed. So let me actually, because I didn't include the peaks here, but I do have it in the previous lecture. Here. Do you see it? Yeah, so those are the pixels per frame. These are 15,000 frames. So if we divide that by 30, that will give us the number of seconds. And this is the red region of the eyes, the blue region of the on top of this area, and the black region of the full face with the mouth. Now this is sadness. So sadness has a different signature, as you can see, than happiness. And these are the micro movements. So now what we do is we take this speed, right? This came from the positions of the pixels, like what I just explained, X comma Y at time T plus 1 minus X comma Y at time times t, and then the delta x and the delta y, I pass that through the Euclidean norm, and that gives me a number. And that's for the first frame and the second frame and so forth. So these are the frames. For each frame, you get a number, and that's the scalar value. It oscillates in each one of these. So then I take that number, and for each one of the peaks, I divide the value of that peak by the sum of the value and the average number of peaks between the minima, the two minima surrounding the peak. So I travel through the entire series and scale the amplitude. And so that's the scaled amplitude of this waveform for each one of them. And this is for sadness. And so happiness covers the entire range from 0 to 1. Sadness goes up to 0.85, maybe 0.9 or something like that. 0.85, so, no, 0.9 for here. So, and this goes from pretty much 0.1, and this one goes from like 0.5. So that's the range, the normalized amplitude range of these one expressions. These are the gamma signatures. So anger, disgust for each one of the regions of the face, and so forth. The PDFs, and you can see right there that there is a difference between disgust, anger, and happiness, and sadness, surprise, fear, and contempt. And when you plot them on the gamma moment space, they separate. So anger is kind of has a place of its own down here, and that corresponds to this. And V1 is pretty different, it's differentiated. And that makes sense because it's this here in the area of the, when you do the angry face, this has a lot of expression there. So that actually is quite distinguishable. Let me see, anger. So V1 is over here. It's the most predictable. And V2 is noisier. So that's what we get from this data set. So here you have sadness, fear, surprise, and contempt. That's where they fell. And this is anger, and this is disgust, and this is happiness. So, all right, so that, now I took, let me go back then to what we did here. So I took, this is a rotated version of the gamma moment space. So I took then the movie, the entire movie from this video, this movie, and I computed chunk by chunk, so window by window, the gamma, I estimated the gamma parameters. And so this is the gamma trajectory for the upper region. The blue is the middle region, and the black is the lower region. So that's where they fall. So from here, we can kind of deduce that the overall narrative that she was telling us falls between, primarily between disgust and happiness. It's away from this. So notice that her narrative contains all of the different micro expressions, but she has a lot of, she's kind of, if you look at the movie, she's not like angry the whole time or, you know, disgusting the whole time, or she's more like kind of in a good mood, telling you the whole thing. So what I would like us to do is take for each one of us those reference points, right? And and then take a narrative and then chunk it up to get the gamma frame by gamma frame, like I did here, and see where it falls, like if it matches our narrative. And that's a big question, like it might not at all. Like in her case, it's not like she was angry the whole time or anything like that. And it's not like she was disgusted or the whole time. So it's kind of makes a little bit of sense. So that's one thing we can do. These are just different ways to plot the same thing I just did before with color maps. So these are the frames. So I ended up with like 36 frames. And by frames it's really each chunk. So I say chunks because it's like chunks taken at, and I said here 5-minute intervals with 10%, but I think that that's a mistake. I have to look at the code. In any case, I can check that because I have the feeling that I did 1 minute, but let's assume that I did 5-minute intervals. So that gives me good confidence intervals on the gamma space parameter plane. So I take from each point in the gamma parameter space here, from each point of the trajectory, I measure the distance using the air mover's distance. I measure the distance to that. I measure the distance to disgust, happiness, anger, and so forth. So the reference signature of V1 and the reference signature of V2 and the reference signature of V3 for each one of these. So that's what I'm doing there. So frame by frame, and then that's a number. So, and the air mover's remember is the difference between the two histograms. It's like it's an effort measure of the effort that it takes to convert one histogram into the other. And so when you have a low number, it means that they're very close. That's a close similarity. It's a measure of similarity. When they're yellow, that means that they're very different. So the blue here are the ones that were closer in anger, disgust, and happiness. And that's what it is. So this region here. The other ones over here are in the yellow region. And then I labeled, so anger, disgust, fear, whatever. And so this is for the V1 region and for the V2 region. And then for the V3 region, it's actually more colorful. So you see that there is a lot more variation.
I had one question.
Yeah.
What is it? So when you say so what is being compared again with anger?
It's so what's compared is the histogram of micro movement peaks
from
the anger reference point and each frame of the trajectory that I built. So this is like, so this is the anger reference point for V1. And this
what is the duration for each point of the trajectory? So
it should be similar. So each point on trajectory, say if I use a 5-minute interval with some percentage overlap, then we should aim for a similar reference interval.
I see.
So this is like one interval. This is like one interval, but then because this is the narrative of a long movie, so like 18 minutes. So this is just like, say this is just 5 seconds long, and this is 5 seconds long, 5 seconds long, 5 seconds long, 5 second times, however, you know.
So when you're looking at a particular emotion, we are not, because this is a analysis of motion, I think we are rightly assuming that each emotion is not just a static phase configuration. It's actually movement towards, like, it's a dynamic thing. Emotional expression is a dynamic thing, and like it would have an interesting starting point and then end point, and that's the trajectory of the emotion.
Right. So it's the trajectory of the emotion. So we have a reference emotion. We have 7 reference emotions.
Yeah.
And when we're talking, it's complex, right? We have a little bit of happiness, a little bit of sadness, a little bit of disgust, you know, it's very dynamic. But this, and I don't know what this is giving us. I'm guessing it's giving us something like the flavor of the sentiment of the narrative that you're telling. So what I want to test, I want to test that hypothesis. When I want to test if you're, because in her narrative, it's very mixed because she's explaining how to build these emotions. So you have a little bit of everything, but it's primarily an upbeat narrative. So it's all like happy faces and so forth. So it's tending more towards the happiness, disgust kind of, right? But now we have a way to localize references, right? And and see in a narrative what's the prevalent sentiment. Now we can play with this. We can play with this. And once you have your reference, that's why I ask you to build the reference of the 7 things. But to build it in different contexts, like individually, yourself, when you're alone, and also in a social context, that's gotta be different. So like among ourselves in a Zoom, that's gonna change probably. Or not, maybe steady, but that's the question, right? So that's
no, I like
that's
this.
step
I like
one.
this because especially because I think it's doing more than just recognizing expression in a static picture. It's doing recognition of emotions in a constantly moving, real-time talking.
So that's the nice idea. The idea is to take this to the next level, right? So now you have a narrative and you pass it through this thing, and you are quantifying probabilistically where you are, like.
So the way I've seen the kind of algorithms I've come across from AWS, Amazon services, they sort of what you see is you see a video, and at each point of the video, it will have a changing probability of the expression being something. So it's like, oh, the algorithm's detecting 50% probability of someone smiling or 50% probability of someone angry. So, but it doesn't do really well. The numbers aren't really good until you make a static phase. So it's only when you do and stay like that does the AWS service show you like 90% smile. Otherwise, the number probabilities aren't good. So I think this is a different approach in that way, that you're training it on a data which is dynamic in nature, and you're training on dynamic features and not particular configuration. So that's nice.
Yeah, so what I'd like to then do is, and also because this is the first time I do this, so I'm experimenting with different windows and different. So my limitation here was like the length of the video was limited, and was but we have more room for playing around with it. So the length of the video, the type of narrative. So we would have to construct like a narrative. So maybe a sad narrative or a happy narrative to see, or a narrative about disgust and things, that are, or a fearful narrative, like a terror thing or whatever. So to see if it actually drags it to the region where your reference emotion, to see if it drags it there, or if it, first of all, the first question is how do your reference emotions distribute in this space? Are they distributing like hers, like we got a clear-cut differentiation here between happiness, disgust, and anger versus the other 4, and anger is a little bit on its own place there. So I'm curious, like how each one of our reference emotions distribute, because that might localize us as people in different domains. And then given that, how each one of our narratives is going to localize with respect to our references, but also later on with respect to other people's references. Like, since we have all the references, we can plot all of these together, and we can see like a given narrative, how it localizes with respect to you and how it localizes with respect to the other person. Because also when we do this socially, like in the Zoom, things are going to shift around, and we're going to have people influencing other people and shifting the conversation one way or another, etc. So the narrative in a social context is bound to change a little bit from the narrative on your own. Like if you are in front of the computer just saying the narrative versus you're now in a group. And so those are all open questions, like, is it going to change? So this is the first part that I would like to complete. But then the second part, which I haven't, I mean, I did it for our 10 people Zoom meeting, but I haven't done it for our 3 people here that I will continue to show with G, Mona, myself, because the voice also influences. So in the network analysis that I did with the 10 people, I included the voice. And you remember those results, right? We had like a very interesting result with that. But I'll revisit this just to after this. So then this is another way to plot the same thing, right? So that's the Ermüller distance, which here is the color code, but here is just the line here, the curve. So telling you that essentially the same thing, right? The happiness and the yellow one is disgust dominate here. They are the ones closer to 0, meaning so you're closer to happiness and to the yellow one, disgust. Anger is a little bit farther away, and the other 4 ones are definitely farther away for the V1 region. For the V2 region, and then the V3 region is the more colorful one that is changing actually more. And that's the mouth. So that makes sense. So that contains the mouth. She's doing a lot of stuff with the mouth and talking and so forth. And so here about the 10 point here is closest to happiness, and then that departures from that, and then it's like closer, anger is closer here and so forth. So it's more dynamic. So this is like the decomposition of what we see here, right? That there we see it as a point, here we see it all dimensions. This is another way to plot it, another way yet to plot it through the histograms, because remember we're doing frame by frame the histograms, and this is all the points that fall in the histogram for disgust, and then for anger, and green is for happiness and so forth. You see how they are different, and that's the Ermüller distance, how they distribute. And then I did some non-parametric pairwise rank sum test comparison just to see which ones were not significant, so, and which one were, and so forth. So the star is the alpha level of 0.01, and the circle at no, the other way around, I don't remember how to see the code. And then the ones that don't have a star or circle were not different statistically and so forth. So we can do some testing. Then this is the trajectory for V1, V2 and V3, the trajectory, and these are the reference points on the gamma plane. So this is where they fall. So these things down here, right? They have higher noise. So you can see their higher noise, lower noise, and so forth. So this is also informative, and this is the trajectory. It's all squeezed there, and these are the histograms, and you can see the dispersion is higher, right? The histograms for each one of the phase. And so for the paper, I'm proposing like as motivation to characterize staged versus spontaneous, getting these references for individualized reference set. And then see how they differ, or if they don't, or if they are invariant when we do this in isolation versus when we do it in a social context. Explore ways to automatically stratify a group. So this is us, and we look at the references and we see if we group differently. Or if we all fall in similar locations. Now, the reason why we can do this, because the micro movements normalize, standardize for allometric effects of size. So my eyes to nose to mouth length might be different than yours, but we normalize for that. So we can then put everybody on the same parameter space. And then the narrative thing is what I really am kind of curious, because again, it's just in real time we can do this. Whose narrative is close to which 7 fumes and from whom. So we do it, the narrative with relation to our 7 references, but we can also do them with relation to the other references, because we'll have them all. So we'll see where we fall. And particularly if we do it in the social group, right? In the social, in isolation, that doesn't mean a lot. But in the social group, it might mean that we may pick up a way to, like when we are agreeing on something with that person. I don't know. It's just, and then others, it's like what other things we can think about, because now this opens a lot of different questions. No, this is the trio thing that we did, that I showed you before. And all we did was just, we sat there and did the neutral thing. So we just did that. And then our idea was to just do a staged, and we're just going to compare stage versus neutral. But then I started to crack up, and then G led the whole thing to like just, and so G is like really going for it. And so at some point, so what I did was I took the frames before G started, because that's kind of, we're still trying to pose. And then the other frames, and I divided that into posing versus spontaneous, but staging versus spontaneous. I mean, it's a little bit arbitrary, so don't put too much money on this, but it's interesting what came out. So then what I did was I just I cropped using Clidio each one of us from the neutral and the with Clidio. And then I for the stage and the spontaneous, I did the same. I cut it, I cropped. So this is I'm just showing you the 3 things, the 3 of us. But I did each one individual. It's just that it was too much to put all 6 frames here, but with Clidio you can get the whole. Yeah, I mean, this can get a lot of fun. Okay, so then what happens? So I characterize the neutral reference point for each one of us, and they span a plane for each one of the neutral, staged, and spontaneous. So that gives me kind of a sense for each one of us. So this is Mona's, this is G, and this is myself. So in Mona's case, and this is just the neutral thing, or is it the whole thing? I know it's the whole thing. It's not the neutral, the whole thing. Okay. So you can see each person individually, right? So went from neutral here, down here. It went from neutral to staged in the cyan here, and then to spontaneous. So that spans a plane for V1, V2, and V3. But G's planes are very different. But that makes sense, because G was like really leading the whole situation here that we got ourselves into. And so she goes from neutral. This is the neutral, and then she goes to staged and then changes to spontaneous. So this is the biggest change here that I see is the black, which is the mouse. And then this is myself, which is different from, it's the opposite of Mona. So I start out from neutral, go to stage, but then lost it. Then I go, all my face goes to spontaneous because really that was what happened. And then this is the trajectory. So this is the trajectory for Mona, for the 3 phases. And this is going from stage to spontaneous. I didn't put neutral here because it's far away, so it shrinks all of these. So each one of them. So in Mona's case, they stay within the cloud of points, pretty much. This is the stage, and then it goes to spontaneous, and it's kind of, you can see each one of the regions. And then for this is G, and in G it's interesting because the one that really changed here was the mouse going from staged to spontaneous. So and she was driving the whole thing. So I'm curious when we do the network analysis, if she comes out like leading and stuff. This, I don't know what happened there. So they're like the spontaneous part for the mouth just went off. And I don't know if that is noise or what the heck. And then the eye region is more, but it's like there's a plane, and then the spontaneous part leaves that plane. So there's a plane, which is like this plane is like the stage part, but the moment it leaves the spontaneous, this is the spontaneous part. So it really, and the mouse is the one that drives it. So very interesting. And this is mine went from staged really to, like I staged only at the beginning, but then I lost it, and then it just goes to spontaneous. So anyway, so this is all I've done with it, like last night, pretty much. But it's beginning to show promise, because I think that we'll start finding, you know, interesting things with our narratives. First, so it's a stage by stage. So first we're going to do the reference to see where we fall. Questions there is whether each one of us spans differentiable references that are well localized. Then we're going to plot everybody on the same parameter space to see where we all fall if we group spontaneously in some part of the space. And then we do the narrative, see what the narrative, where the narrative falls in relation to all these references. Let's do this first for the staged version of it, because it's easier. And then we can settle on a stimuli to do it spontaneously. So like, hold on a second, let me get rid of this. I was compiling some links that Hannah suggested. So let me see if I can find some. And so you can, so if you want to suggest some links, hold on a second, let me share the screen. So for example, this one is, do you see the YouTube thing?
Yeah.
Yeah.
Okay.
1, 2, 3, let's walk forward. Keep walking. Keep walking. Keep walking. Now we're gonna run.
Righteous! Whoa! Come on, come on! I ran.
Okay. So whatever, you just find something. Let me get rid of it. It's still doing things. All right. So we can all settle on some of these and try to watch it while we're recording our faces so that we, Theo, can you?
Ideas of that. I have some good ideas. I remember some videos.
Yeah, so I mean, this is the part that we should agree on a uniform set, and so we all do that, but we also should find a set that is like we resonate with, and so we do that too.
Would it be music for sadness?
Yeah.
Yeah.
Yeah, so let's but that's part two. So part one is easier. Let's do part one, which is the staged emotions, and we just follow the prescription. We do them by ourselves, and then we do them as a group. Okay. How many people have Joe's stuff? Just to give me a sense. 3 and 4 myself. So we would have to convert yours. So let's just distribute it. So you give yours to each one of us. Like, who's gonna give me theirs? Okay, Melissa, I'll take yours.
Okay.
And you guys?
You mean the videos?
Yeah, so that we process them and create the MATLAB files, because this is the first thing we need to do in order for us to do this. I'm gonna try to go through the MATLAB scripts.
Yeah, are these scripts shared yet?
No, yeah, so I put some of them in the box. So
Okay.
let me see where they are in the box. But I'm just building them as we speak. So code MATLAB, let me see. Phase data analysis.
Yeah.
Okay, name or. So if you see, there is one that is called plot gamma traj 7 universal micro expressions. That processes that's an example of how to process these 7 universal micro expressions.
I don't see it on the box though.
Really? Let me see.
In phase data analysis, right?
Under phase data analysis, so there is class fall 2020 code MATLAB phase data analysis.
Yeah.
You see it?
The only wait, I see plot underscore e bars, em distance, build record amplitude, and then slide win. There are like 4.m files, I think.
Really?
None of them are.
Okay, hold on. Let me share my screen.
Oh, you know what? I see it. It was just showing me. It was just showing me less results on each page, so I have to.
You have to go to the next
select.
page. Yeah,
Yeah,
it happens to me all the time. Yeah, so I had to remember to go to the next page. So do you see my screen here?
Yeah.
Yeah. So that's that. Then what's
I see the plot gamma.
Okay. Yeah. So okay. So this thing here, plot gamma. Let me see if I can get my MATLAB thing. So, do you see MATLAB here or no?
No.
Because yeah, I share the thing. Hold on a second. I gotta share the screen. How about now?
Yep.
So, okay, so this is to plot those things. Let me just close everything I have open. This is the full movie. So I'm using 1 minute length here. Overlap 0.1 means 10%. This is the frames per second. This just defines the points to create the PDF. So to evaluate when we empirically estimate the distribution, to evaluate the distribution every 0.01001. The slide window trajectory is going to take this segment every 1 minute with 10% overlap. Is going to create a trajectory here. So let me just go over it. I think it's in the other. Yeah. So all it does is takes a segment length and overlapping, and then the frames per second, and then the actual trajectory that you want to deal with, which is the whole movie that is processed. This movie, full movie, processed. And then it just goes through the trajectory, which has, like however many frames, say 1,000 frames, and it just travels through that trajectory, taking chunks of 1 minute each, which is 60 times 30 frames per second. So it takes 1,800 frames at a time with 10% overlap. So it leaves, it does that every other 10%, and then creates a whole trajectory, which ends up being a cell array. So if I run these, then I'm going to create this new V1, which is the cell array that has the trajectory. I'll do that now. And for each one of them, I create this build record amplitude. So let me just do that, and then I'll show you what comes out. So new V1, so ends up having 36 frames. New V2 has 13 frames, and new V4 has 34 frames. And they're different. Remember, they have different number of points. And so so this is these are the number of points for the first cell, and then you have 36 cells. So new V1, sub 1, like if you were to plot that, looks like that, right? That's the first frame. This is the second frame. Very different, and so forth. So you have 36 of these frames. Each one of them, now you put it through the gamma parameter estimation, which is this one, build record amplitude. So if I go now to the first frame, okay, here's all the structures. The time series is what I just plotted. The micro movements is the standardized peaks. So it takes the peaks from here and then it scales them. And then the micro movement full, it's the same length of the time series -2 because it does require to have the peak center between two minima. And so it drops the first and the last. So if I were to plot this guy, I said I = 1. Say micro move full. That's what I get, right? Let's say that I plot instead the time series. This is what I get. So from this time series, we scale those peaks, right? And that's the scale version of it, so that we account for those differences in length of body of facial points. Okay, so that builds the movie. And now I had processed this phase 7, which contains the 7 micro expressions. So let me see. And that's sort of where they fall. So that was what I was showing you before. So anger is kind of over here, and happiness and disgust, and then you have the others. So phase 7 is something that I processed. So it has V1, V2, and V3. So these are the references. So V1, so again, has all these parts, but it's just like the one value for that reference, whereas the other one has all these different values, 36 frames for V1, right? So it would have 36 of these guys. Is that clear? So one is just one point on the gamma parameter space, right? And the other one is a whole trajectory. So this is the trajectory. So now we call it movie phase. And if I go through, I run I through the size of the frames, which are 36, each one of them. And so then I can plot the whole trajectory. So here it is, right? That's the trajectory, right? So it falls between these two, away from anger and away from these other guys. And we can, of course, throw a line through, draw a line through each one of these points. I didn't do that, but I did it for the other one that we did with G, Mona, myself. Then I can obtain the air mover's distance between each point in the frame and each phase region, right? So each reference for each phase region here. So that then I can plot it in various ways. So this is one way to plot it for V1 and V2 and V3, right? So any questions so far? Then these are the color maps that I showed in the PowerPoint for V2. And then for V3, which is more colorful, as I was mentioning, it changes more, has a broader range. And then some parametric statistics just to compare. So what the heck is the, yeah, so if it's less than 0.01 is the pentagon, and less than 0.05 is the circle, okay? And then for V2 and for V3, each one of the regions, you can, and we can run other non-parametric statistics as well. Now this is the gamma parameter plane. So this is the trajectory points here, and happiness and disgust and so forth. So this corresponds to which one is the that? Let me get rid of the legend. Right, so this is the correspondence. So these guys over here are here, and these guys down here are the higher noise and lower values of the shape parameter. So there's a correspondence here that we can also lends itself to interpretation and inference and so forth. So with this, and so this is for each one of the for each one of the phase regions. So this is for the middle one and V3, the mouse, which is usually more expressive. And then these are the PDFs. That's for all the different ones. And for the trajectories. So these are the, in red is the PDFs of each one of the chunks in the trajectory of V1. V2. And V3. And as you can see, it spans a broader range. And that's it. So that script is in box and can be adapted for each one of the reference emotions that you're gonna, just change the name of the file, and for the trajectory, which would be your narrative, so you can record a narrative and so forth. Is that clear? We can do it together, so it's no problem. Yeah, I'm playing with other things, like incorporating the sound. We can do sound analysis with the MIR toolbox to do voice analysis. Like for the Zoom stuff that I did with the lab, I incorporated that for the network analysis. So that's another waveform that we can bring in. Because it's interesting how to, like, this is emotion recognition, but from the visual perspective, but the sound, particularly when you're watching those sad movies and the music kicks in, you like cry like there's no mañana with this music, right? So the sound really plays, and so just like there are universal micro expressions, facial expressions in the visual domain, it's got to be in the auditory domain. So we could actually discover that ourselves. So we could do that. Any questions?
Does the length of the videos matter? Like, does everyone's video have to be like a specific?
Yeah, we should settle on a length. Like we should settle on the length of the video, and then once we run the script, let's settle on a good window and a good overlapping window, and then we can play with that too. See how much it changes the outcome.
Yeah. So first set of data is just imitating the emotions. But are we going to eventually also do this sort of trajectory for the narrative?
Yeah.
Where we record a narrative and then test whether we can detect different emotions in that.
Yeah, so we should like settle on what narrative are we going to. Like, I mean, for the Zoom thing, we just did what we had for breakfast. Oh, I had, banana, whatever.
Yeah.
So what narrative you guys would like to, I mean, and we can play with different narratives, like something happy and something funny and something sad and some, I don't know.
Yeah. It'll be good to keep like it less complicated with like maybe 3 emotions and have a narrative which contains 3 components like that.
Yeah. So I would say, so I'm curious, like if you have something that is predominantly happy, like a joke, that you're telling a story of something that happened to you, where does that fall versus something that is predominantly sad, and if that shifts, and then a mixture, like if we're a mixture of it, like we could do sad and happy, which are 2 easy extremes, see where they fall. And then like a neutral thing, like what did you have for breakfast? It's neutral. Like, although in our group, when G said what she had for breakfast, they all laughed because everybody has like coffee and tea and your yogurt, whatever. And then G's like rice and beans and and a croissant. But it's very funny for us because G eats a lot, but she's very skinny, right? So we don't know what she does, even when she was pregnant, right? And she eats a lot, and it's very funny because of that, because we know in the context, we know like she eats a lot of food. So here we are all having tea and coffee for breakfast. She's like, and I had rice and beans and beef and this and a croissant for dessert, and we're just laughing because of that. So it wasn't neutral after all. So what should we do? I mean, this is like, this is it. Now we are in the mode of like, let's collect the data. So should we collect some data and come back, or to try to process some? Or I have Hannah's data, so I can start processing that, and then we come back, and I'll run the stuff, like I'll run this routine, I'll run this script through Hannah's data. I mean, I don't have a narrative for her, but like through the 7 references.
Yeah.
Can we watch you process it? Like trying
That's what I'm saying. That's what I'm saying, that I'm going to, do you want the whole thing? Yeah, let me just give me enough time to download the files and put it where I need to put it.
Just to see like what that process looks like, because I can't do it on my end. So
yeah, definitely. So I was in the process of getting Hannah's. Actually, yeah, I'm here, so I might as well do it. So, okay, so I'm going to share the thing. I think this is the one, yes. All right, so you see, this is Hannah's. Do you see my screen, my Explorer with, hello?
yeah.
Okay.
Sorry.
That's okay. So this is Hannah's anger. So, and she did it several times, which is like what we should do. Okay, and so this is, let me see, how long? 49, is that the time? Yes,
Yeah.
that's the time. So 49 seconds. Is that seconds? I suppose so.
Seconds, yeah.
So let's see what it looks like. So this thing, you're not gonna do this, but essentially Joe wrote this wrapper and it has this file that I just have to edit it and get the name of the file in it. So that's the name of the file. It's an MP4. Just save it. And I'm just gonna run that. And that's gonna create the skeleton.
So this is using OpenPose now?
Yeah, this is using OpenPose
Okay.
plus there it is. So that's plus the wrapper that Joe created.
Okay.
So that's creating, so the number of frames, so
that didn't take long at all for 49
no,
seconds.
no, it's very fast. I mean, I have a GPU.
But you have a GPU, right? I
Yeah.
also see OpenPose has a CPU only version too for Windows. But they say it's like 100 times slower or something than
Okay.
GPU. But I think
Yeah.
it will still be a good experience to take a short video and convert it, even if
Yeah.
it's just using CPU.
Yeah. So I mean, it's pretty good. And the blue thing, I think it helps because we have less noise in the background. Though I did the one that we did at Gmona myself with no background, it was okay. But for a paper, it's more uniform, you know. People always complain about all kinds of things. So.
Yeah.
So it'll create a .mat file, and hold on,
I think that's the folder anger edge processed.
Huh?
Anger_edge processed. Is that the folder where
That's like a
processed mat file is?
data, and then it goes into the MATLAB file.
Yeah, so I mean, it's just doing the thing. So we'll just have to wait. So that creates the .mat file, and I'll take that into the directory where I have the script. And then run it to create the 7 reference points and see where they fall. Then I'll ask Hannah to give me like a narrative. I mean, to create a fake narrative here, although there's no narrative, but to create a fake thing, I could just merge all of these movies using Clidio and create the trajectory that way and see where it falls. It's like a bundle of all of them.
Is Joe's wrapper available on GitHub or something?
It's what?
Is it available on GitHub, or like if I want to run this on my?
Yeah, it's the whole thing is in Box.
Okay.
Yeah, in Box. Let me see, where is Box? Do you see Box there?
Yeah.
Let me see where that is. Richa, you remember?
I can copy it into the class folder.
Yeah, let me just, but you remember where it is?
SMIL experiment protocols, and then there's an OpenPose how-to.
Yeah, let me see where that is. Gotta be in the next. Here it is. OpenPose how-to. So Richa can copy this in the folder for the class and share it with everybody.
Thanks, Richa.
And so this is for the face, And this is for the body. We can do the face for now and then learn the body later on in class.
Oh, that's be cool.
So is this thing still going? No, I think it finished. Yeah, here it is. So this is the anger segment. It's a .mat file. So let me copy it to MATLAB. Let me close. And paste. Okay, so yeah, so it has 25 frames per second. Here's V1. So that's the 69, the 28 values. Let me see where I process. I have to process it first, I think, to get the speed. Do I do that here? Ah, yeah. Get speed trigeminal does that. So the full movie. Let me open a new like a new script here. Just so that we see. And so this would take V1, V2, V3 here and give you the speed. So the speed now has 34,607. Because that converts, so remember is 27 points, no, 28 points. So the original number of frames is 1236, right? So 1236 divided by 25. In this case, the frames per second is 25. That's 49.4 seconds. And then so that's times 28 points times 2. So 2 is for XY, but remember XY, we subsume that into delta X, delta Y and get the norm, and that's one scalar. And then this becomes, we reshape these to be, for to each of the 28 points, we get a scalar times each of the frames. So that is 34,607 points. Then we can take, chunks of that to create a trajectory, for this. But it's going to be that this would be just our reference in this case. Again, 49 seconds seems okay to do that. So the next step is to create, so that creates the speed. The next step is to create the record. So this would be Hannah, and we just did what? Anger V1. And then we do V2 and V3. Okay, so we run that. Oh, yeah, we gotta give it the X thing, which is just the values to get the evaluate those points of the PDF. All right, so now this has a structure with a time series, the micro movements, the max indexes where they occur in case you wanna compute something about the temporal profiles. And this is the gamma signatures and the confidence intervals, the micro movement full, and then the points, the moments, the 4 moments, and then the PDF X values and the corresponding Y values for the gamma. So that's that. If we wanted to plot that, that's just like the 3 points. We don't have like a trajectory, but we could try and fake it with these. Create a trajectory instead of grouping all these points. So we could try to do that. And then okay, let me change the names. And this is where we have to play with. So this is segment length is 30, but we could do every 5 seconds, for example. We have to play with it. That would be 5 seconds. 30 is the number of frames per 1 second. 60 is 1 second, 1 second long. No, sorry, times 5. That would be 5 minutes. So that would be 5 seconds. 10% overlap. We did this already. Okay, I'm going to get rid of those. And so this would be our reference signature. Whereas this would be a trajectory, but it's fake, okay? So we need a narrative. We need her to give us like a movie of a narrative. But I'm gonna use the full thing. Is everybody like understanding what I'm doing? Questions? Questions?
No.
Everything okay?
Yeah.
Okay. So this is a fake. Narrative. I'm just going to use the full speed. So remember, speed has 1 by 34,607 frames, which come from the combination of the 28 points in the face plus times the number of frames, which is 30 times 49 seconds. I'm sorry, 25 frames per second. Oh, I should correct this, 25. Yeah. So this will create a trajectory. And now we have this new V1. For V1 has 82 frames, 36 frames for V2 and 78. So it's like unfolding this whole signature, reference signature. So if we plot that, it better falls close to the thing, but I don't know. So we'll see. So let me see where it
Why are
is.
the number of frames different
The number of frames?
for
do you
V1,
mean?
V2, V3?
Huh?
You said V1 has 82 frames. V2 has
Yeah, because
36.
this one has 27. So we start out with V1, right? 28 points in the region,
I see, yeah.
14 points in the region above the lip, and 27 points in the lip plus the face contour. So it's reshaping. So in MATLAB, to reshape this, you just call the command reshape, and then it's going to be 1 times, you know, if instead of being this multidimensional matrix, you can make it into a 1 by something in vector array. And so to do that, you have to do 1 times 1 by, and then multiply these guys, 1236 times 28. The 2 subsumed into 1 scalar, because remember, we go from vector to scalar, right? And so that's like 1, 2, 3, 6 times 28. So you end up with that minus 1 because, oops, what did I do? Okay, yeah, so that's what it is. Because you lose the last one or the first one in the reshaping. So now we need to plot it, right? Let me see. So let me use this code to plot the. Now in this case it's different because we just did the one thing. So I'm just gonna plot one guy for each. Okay. What did we call this? The reference we call Hannah Anger, right? V1. Yeah, scale it is just to define it, so we can say set it to 2 or 3. It's just for visualization purposes so that we see better the values. We don't need this yet. So that's just that point for V1. And of course we can plot V2 and V3. Just change the color so that you know which one is which. Oops. And then I'll draw a line. And we can put a legend. Okay. Let me think about how to draw the line better. But no, it didn't like it. What did I do? Oh yeah. Hold on. Okay, so I need to draw the line, but I had to think about how to do that. So this is the plane that the three regions like span for reference for anger. And then we would do that for all the others. So any questions there? Let me do another one. So we did anger, let's do happiness. Let's do happiness. All right, so that will run there for a while. Any questions? So I'll run Hannah's thing and plot them all like that, like I just did with the scripts, and upload Hannah's script also. So that should be the first. I mean, I don't have a narrative. I just made, fake that by chunking the whole 49 seconds, but that's kind of weird. Although we'll see what it looks like. So I'll process that and see what it looks like. So why don't we reconvene? So hopefully this will not take very long and I can at least process 2 or 3 of the emotions. So how do you want to do this? Like we could reconvene at like, I don't know, 4:15. That gives me about half an hour. If you guys record like 1 emotion or 2, we could do somebody's face.
You have like a lot of us have them in the box already.
Ah, really?
Yeah.
Yeah.
Ah, okay. So who wants to so should we process some?
Yeah,
Yeah.
you can process mine.
Maybe we can do like everyone's happiness or something and then compare.
Yeah. Happiness is easy.
Right. Okay,
Yeah.
so we can do that. I'm gonna do Hannah's happiness. Who else do I do? Melissa, do you have yours or?
I don't have mine, but I can just do it really quick. So.
Okay, yeah, just do it and put it there and then I'll process it. Who else do I need to process?
I have
Laura?
some in the box.
Okay, so I'll do Melissa and Laura and who else has, well, I'll just do them all. The only thing is that it takes a little bit to process. So I don't know if,
I can process like 2 of the files and send it to you if you want to like.
you can put it in the box. I just download it.
So I think it's like 6 of us have done it, so I can do half and you can do half maybe.
Okay, so let's put them in the box in each of the, like if you do Nipun, his MATLAB, if I do Lara and Melissa and so forth, so we put the MATLAB right in the thing. Now I'll just download it and run the script.
Okay, so who all have done it? Oh, I can see it here. So I can do Kaylee, Theo, and Elizabeth.
Okay, so I do Melissa, Laura, Nipun.
I haven't put anything there, but I can try and just put something there now.
Yeah, just put something. We can always change it. It's just for trying. Just try to look happy since we're gonna do happiness. I'll try to do mine too.
Just FYI, my videos were roughly about 30 seconds each.
Yeah, mine were like 20 seconds because I just did
like
the thing 10 times.
10 to 20.
I
So,
turned the volume off and it kept putting the word up that I was recording no sound and I didn't want to record sound. So I like stare and read the message on every single video. And that's why I'm like staring at the screen.
Why is there an issue with voice?
What?
so this will be like our first try. We can make it better, like settle on a number of seconds and how to do it so that we do it on a formula. But this is just to see like what it's like for the whole group.
Sure.
So I do Melissa, Laura, Nipun. Who else? I guess I have to do myself. Richa, you do the others?
Yeah, so I'll do me, Kaylee, Theo, and Mona.
I can do my own.
Okay.
Jaiwei, do you want to do these or did you upload the movie?
Yeah, I uploaded them.
Okay, so I can do yours too. Okay, so we'll reconvene like at when? 4:20? I think that will give us enough time.
Yeah, that celebrates New Jersey's latest decision to marijuana.
Yes. Okay, guys, 4:20 and fingers crossed that we took Pennsylvania or something. Okay,
All right.
see you at 4:20.
Liz, I think Mona can do 2 too.
Okay, Mona, you want to do Jaiwei and Melissa?
I can do those.
Okay, and then so I'll do the others.
I'm recording mine right now, so it'll be like a couple minutes because I need to record mine. So it'll just be a couple minutes and I'll post it.
And Melissa, are you recording it on Zoom?
Oh yeah. So I guess
Because we need a blue background as well, which I
So-
don't know how to.
yeah. So I'm
Might
gonna,
have to leave the meeting for that. So just in case we are not in the meeting.
Yeah, then you can come back.
all right.
Okay, see you soon. Bye.
The happiness.
Yeah, just happiness. So wait, I want to make sure we're not missing anyone. So I'm doing me, Kaylee, Theo, and Elizabeth.
I'm doing Laura, Nipun, and myself.
And you have Hannah. So that's
Huh?
cool. And you did Hannah too already, right?
I did Hannah, yeah.
And then Mona, you're doing
Myself, Melissa, and Chai.
1, 2, 3,
Jaiwei.
6, 7, 8, 9, 10, 11. Yeah, that's good. We got everyone.
We're good. All right. See you soon. Bye.